Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello students, future engineers, subscribers and viewers. Here is a topic on Venn diagrams, simple problem only just to set up uh, problems and light analysis on problems on sets. And this is a good way of dealing with set problems. So this is the principle. We have this first case here. This is used in set operations and problems regarding sets. So we have to denote the group into this circle here. And if they overlap, they belong to set A, for example, then we have set B. Then the members common to sets A and B is placed in this region here, common to both sets. So X is elements common to sets A and B. And therefore, if the total number of members in set A is A, then exclusive members of set A would only be A minus X. So that's exclusive members of set A. Exclusive members of set B would be B minus X. So that's it for that case. For another case, let's say we have set A, set B, and set C. So in this case, since sets A and C are not overlapping, that means they have no elements in common. So if we put X here, this is the members common to sets A and B, exclusive members of set A. If Y is the number of members common to sets B and C, so B minus X minus Y would be the exclusive members of set B, and C minus Y exclusive members of set C. So B minus X minus Y exclusive members of set B, and A minus X exclusive members of set A. Then A and C have no elements in common. So A minus X this is the definition also. So we are now ready to solve the first example. In a class of 40 students, 27 like calculus and 25 like chemistry. How many like calculus only? So the total number is 40. This 40 here is the sum of the numbers that will be placed here. So if we denote X as the number of students who like both calculus and chemistry, then those who like calculus only would be 27 minus X. And those who like chemistry only would be 25 minus X, where 27 is the number of students who like calculus. Some of them also like chemistry, of course. And 25 is the number of students who like chemistry. So that's the setting up. So 27 minus x plus 25 minus x equals 40. So x is the number of students who like both. So 27 minus x plus 25 minus x equals 40. Solving for x, so x is, we have 27 plus 25, 42 minus 40 minus 52 rather, minus 40 is 12, and 12 is equal to, so cancel x here, transpose negative x to the right, x. So x is 12. Therefore, the number of students who like calculus only is equal to 27 minus 12, and it is equal to 15. So x is 15. Then, in this second problem 2, a survey of 100 persons revealed that 75 of them had eaten in a Chinese restaurant and that 56 of them had eaten in a Japanese restaurant. How many had eaten both restaurants from the surveyed group? So we denote X as the number of persons who had eaten in both restaurants, Chinese and Japanese restaurants. Then since 75 mentioned that they had eaten in Chinese restaurant, then those who ate in the Chinese restaurant only is 75 minus X. And also in the survey, 76 of them had eaten in the Japanese restaurant, so therefore those who had eaten in Japanese restaurant only is 56 minus X. So adding these numbers and equating it to the number of persons surveyed, which is 100. So 75 minus X plus 56 minus X equals 100. Solving for X, 75 plus 56 is 131 minus 100 is 31. So X is 31. Then problem 3, a certain number of graduates from a certain university took the recent licensure exams in mathematics and design, structural design maybe. Record shows that the probability of these graduates in passing mathematics is 4 over 7 and the probability of passing design is 6 over 7. If there were 9 of these graduates that passed both subjects and none of them failed in both subjects, how many graduates from the said university took the exams? How many of these graduates passed mathematics subject only? And how many of these graduates passed the design subject only? So we have math and design, and it is mentioned that 9 of them passed both subjects, so place it here, and none of them failed in both subjects. So meaning to say, if we add these numbers, it should be equal to X if X is the number of graduates. So if X is the total number of graduates of that said university, then since the probability of passing mathematics alone is 4 over 7, therefore the number of graduates who passed, or the number of graduates, the graduates who passed mathematics alone is the probability, which is 4 over 7 of X, then minus 9 because the other 9 also passed passed design. Then the number of graduates who passed the, design only is the probability, which is 6 over 7 of X, then also minus 9. So adding these numbers and equating it to X, so 4 over 7X minus 9 plus 9, so cancel 9, then plus 6 over 7x minus 9 equals x. So 4 over 7x plus 6 over 7x minus x is 3 over 7x, then negative 9 to the right, positive 9. X therefore is 9 times 7 divided by 3. So since 9 over 3 is 3 times 7, so x is 21. So there were 21 graduates from the said university. Then for number 2, mathematics passers only is 4 over, this is the number 4 over 7, 21 minus 9, so that's 3. And passers of design subject only is 6 over 7, 21 minus 9, so 9. Then lastly, problem 4. In the recent joint Christmas party of 2 clubs, there were certain number of participants that attended. There were 150 of the CE club and 84 of the ME club who attended. If 24 members are belonging to both clubs taking two courses, how many double majors? How many attended the joint party? So we have to draw diagrams, circulars. This is the CE group, ME group, and it was mentioned that 24 members belong to both parties. So put 24 here, and there were 150 of the CE club members. Therefore, exclusive members of the CE is 150 minus 24, and 24 members are belong to both, and 84 members of the ME club. So therefore, exclusive ME or ME members only would be 84 minus 24. So adding this, that represents the total number of those who attended. So N is equal to 150 minus 24 plus 24, then plus 84 minus 24, and that is 210 members. So that's it for this video.